Hello everyone, this is Dr. Young, and in this video we are going to name some benzene derivatives, right? So we're talking about molecules that have this aromatic ring in them. We're not going to talk about other aromatics, just benzene specifically. So once we start putting groups on there, how are we going to name them? So first we'll start off with just the mono-substituted things, right? If you're looking at a mono-substituted, so you just have one substituent, one group, definitely always your parent is going to be your benzene ring. So you're going to have something, something, something benzene, and then you name it like normal, where whatever the substituent is, that's what you're going to name as a substituent. And since there's only one group on your benzene ring, you don't have to say like it's a 1-bromo or anything like that. You just name it like you would name it. So in this case, we just have bromo, benzene. So normal rules, right? You call bromine bromo. There's no space between the bromo and the benzene. Same thing over here, you have methyl benzene, so methylbenzene. And lastly, you can call this one isopropyl benzene, or you can call it 1-methylethyl. So you can call it isopropyl benzene, or you can call this 1-methylethyl. Benzene. So it's just kind of the normal, so far it's just normal rules. And again, I don't have to say 1 because there's only one group coming off of these, so that's really all there is to it. Now, what happens if we have 2 groups? So here we're talking about di-substituted things now, right? So now we have a di-substituted, so I have 2 groups on here, and it gets slightly more complicated only because I need to put numbers on here. Still, what we're going to see is that we have the benzene parent, and that in this case now we have 2 groups coming off of it. Same thing over here, we have the benzene parent with 2 groups, and a benzene parent with 2 groups. Your numbering rules are going to, again, be the same as what you learned in all of your other nomenclature stuff, right? So you're going to try to have the highest priority group have the lowest number. In this case, you only have halogens and you only have alkyl groups, so none of them really have priority. And so then you're going to go for how to get the lowest number possible. In this case, I have 1, 2, 3, or I could go 1, 2, 3, but since they're identical, it makes no difference whatsoever. So either way you do it, it's a 1,3 dimethyl. Yeah, however way you do it, it doesn't make a difference. So I'm just going to call this a 1,3 dimethylbenzene. If I go to the one on the right-hand side, I have 2 groups also. And now I could go 1, 2, 3, 4, 5, 6 around the ring. Or I could go the other way. I could say that the ethyl is carbon 1 and the methyl is carbon 2, and then go 3, 4, 5, and 6, right? So depending on which group I start my number 1 at, I can get different names. And this also follows just normal rules, where if you have a tie like this, it's either going to be 1-methyl, 2-ethyl, or 1-ethyl, 2-methyl, you just go by the alphabet. So that means I'm going to go with the purple route here. The purple route wins. So I'm going to be going this way because ethyl starts with E, methyl starts with M, comes before M, so that's how you break that tie. So that means I'm going with the purple route, so I have a 1-ethyl, I have a 1-ethyl, 2-methyl, benzene. And then the last one, I have 2 groups again. Like I was just saying that since it's going to be 1, 3, either direction you go, you decide by going with the alphabet. So B for bromo, E for ethyl. Bromo comes first, so I go 1, 2, 3, 4, 5, 6. Which means then, right, that I have a 1-bromo, 3-ethyl, benzene. And so you just kind of use the normal sorts of rules. Again, only the ending here is benzene. Now, where it gets a little bit different is that when you have di-substituted things, you can also use a different sort of locant system, a different numbering system, right? So this is just a different numbering system. And I'll put numbering in parentheses here because we don't use numbers. So it's a different numbering system. And that's just that when you have 2 groups here, where they are one away from another. So this is your 1-2 relationship, right? Normally we'd say, oh, that's a 1-2, right? That's a 1-2 relationship here. Now we call that ortho. And we show it in a name by having an italicized O. That O is italicized, even though it doesn't really look like it. These M's and P's look a little better as far as being italic. Here, if you have things that are 1-3 from one another, they're 3 carbons away, that's meta. Here, if you have things that are 4 away, or it's a 1-4 relationship, we call that para. So we have ortho, meta, and para, referring to how far away are these groups on the benzene rings. And we can use that in lieu of saying 1, 1-2, 1-3, or 1-4. So for example, if I look at these up here, this was a 1,3 dimethylbenzene, and a 1,3 relationship we just said is a meta relationship. So what I could do instead was I could say meta, and I'll try to draw it italicized. I could say meta dimethylbenzene, and that's supposed to mean the same exact thing. Meta means 1,3, so that would be also meta dimethylbenzene. Same thing up here, I have a 1,2 relationship, so instead I could say O ethyl methyl benzene. O for ortho. You could write O or you could write out the word ortho. You'll see both. And then lastly here, these are 1,3, so then this would be meta. Oh, sorry, not meta. Wait, did I? Oh, I have 2 metas. Yeah, I have 2 metas. I didn't have a para in example. That's fine. This would be meta bromoethyl benzene. So you might also see these ortho-meta paras used to help indicate how close 2 groups are from one another. Please note that this is only for benzene rings. This does not work for cyclohexanes where you have no double bonds. I see students try to overuse the ortho-meta para stuff. Only with benzene rings, that's it. That's the only place you're really going to see it. While we're talking about these benzene rings, there are some common names that are not necessarily fully IUPAC. They certainly can be used, but if you have a benzene ring with just a methyl group on it, you can call it methylbenzene, but its common name is toluene. Ditto, if you have a phenol, you could call that hydroxybenzene, but it's also more commonly called phenol. You could have carbaldehyde benzene, or in other words, benzaldehyde. You can have benzoic acid. You can have aniline, where you have an amino group on it. And so sometimes those are used as the parents, and I'll write that here. So some benzene derivatives, right? They're sometimes used as parents. Sometimes used as the parent chain. So what do I mean by that? If I take a look down here, right, I see that I have an aromatic ring with a methyl and an iodine on it. So I could call this an iodo, 1-iodo 2-methylbenzene. Or I can say, oh, hey, look, I have a toluene here, right? This is toluene because it's a methyl with an aromatic ring. So I could say, oh, no, this is a toluene. This is a toluene here. Ditto, I could look at the next one and say, like, oh, look, I have an OH. So you know what? That's a phenol. I see that I have a phenol in here. And then on the last one, right, I can look at this one and be like, oh, look, hey, I've got a benzoic acid, and I can call that parent benzoic acid. So instead of the parent being benzene in all of these, the parents are toluene, phenol, and benzoic acid. And so that kind of changes the game here. If you do that, your carbon number 1 is always at whatever that derivative name was. So what do I mean by that? I mean, if you call this toluene, that means this is your carbon number 1. That's carbon number 1 because that's where the methyl was. So you're going to call that carbon number 1, period, no matter what. If you call this phenol, you're going to call that carbon number 1 because that's where the phenol, that's where the OH was. That's the thing that made it phenol. So that's your carbon number 1 always. I don't know why I wrote primary. That's your carbon number 1. Have it. Same thing for benzoic acid. That must mean that this is your carbon number 1 for the benzoic acid because that's where the benzoic acid group, that's carboxylic acid group came off of that carbon. So your number 1 always is going to be where that group is coming off. And then from there, you just go clockwise or counterclockwise so that you have the lowest group possible, the lowest numbering possible. So for this one, I'm going to go clockwise. So I have a 2, 3, 4, 5, and 6. so that I get a 2-iodo-toluene. 2-iodo-toluene. There's not supposed to be a space there. With the phenol, I'm going to go counterclockwise, so I get my next lowest number on my bromo. So this is now a 3-bromo, 4-methyl. So 3-bromo, need more space. 3-bromo. I'm just going to erase the whole thing. 4-methyl phenol. And then lastly, for the benzoic acid here, again, that's my carbon 1. I'm going to go clockwise so I can get that chlorine to be a lower number than if I went the other way. And this would be a 3-chloro-benzoic acid. 3-chloro-benzoic acid. And so we can name our carboxylic acid derivatives using these sort of new parent names, these new parent chains. So there's toluene, phenol, benzaldehyde, benzoic acid, aniline, or aniline. You'll also see there's also xylenes, there's anisole, there's cumene, there's cresol, there's all kinds of derivative names. These are some of the more common ones. These are more common ones. Now, here's just a whole group of ones where you may or may not use the parent names. It's up to you. It's not incorrect, by the way, to instead of saying toluene to say methylbenzene. That's totally fine. It's just you will see toluene be used instead. So you should know what that means, and you're welcome to use it also. So this one, I see I have methyls on here, so I could either name this as a parent toluene, or I could call it, dimethyl ethyl something. I'm going to go with calling this the parent. I'm going to say, hey, let's call this toluene. And then numbering things 1, 2, 3, 4, 5, 6. So I'm going to call this whole thing, it looks like 2-methyl, 4-ethyl. So I have 4-ethyl, 2-methyl, toluene. Again, I could have chosen not to use toluene and called it 4-ethyl 1,2-dimethylbenzene. That would work also. Here I see an aniline. I see aniline right here, so I'm going to use that and give myself fewer substituents to name that way. So this is going to be my carbon 1 again, 2, 3, 4, 5, and 6. So to name this, right, it looks like I've got a 5-chloro and a 2-methyl, so 5-chloro, 2-methyl, aniline. Aniline, check. Here we have a benzaldehyde, and I have an aldehyde and I have an OH. So now the question is, do I call this a benzaldehyde? Right, do I want to call this a benzaldehyde, or am I going to call this a phenol? And to answer that question, you just go back to what should have a higher priority group. Do aldehydes have a higher priority group, or do alcohols have a priority group? And hopefully you remember that aldehydes have a higher priority group, so that wins. This is more of a benzaldehyde than it is a phenol. That's the higher priority. And so this is going to be my parent, which means this is my carbon number 1, 2, 3, 4. So I have a 4-hydroxy or a para-hydroxy benzaldehyde. So 4-hydroxy benzaldehyde. Or like I was saying before, you could also call this para-hydroxy if you wanted. Either way. You'll notice that in these previous two, I did not use para or ortho or meta or anything like that because it's not appropriate in these cases. And the reason that it's not appropriate is that the ortho para meta stuff is only used in di-substituted molecules. Both of these two are tri-substituted, right? They have 3 things on them. Right, so if your molecule is tri-substituted, to say that you have a ortho-methyl group is confusing because it's going to be ortho to one thing and maybe meta to another, maybe para to another. So the ortho-meta-para group designations, they lose their meaning if you have more than 2 groups, right? So we can only use ortho-para when we have di-substituted. when you have di-substituted benzene rings, not just any benzene ring. Let's go down to this one down here, far left. This is a fun little molecule. I see I've got a toluene, and I've got a bunch of nitro groups on here. You just name them nitro groups. So there's my 1, 2, 3, 4, 5, 6. Doesn't matter which way you go. Either way, it's the same. And so this name here looks like I have 1, 2, 3 nitro groups, and they're at carbons 2, 4, and 6. So this would be a 2, 4, 6 trinitro toluene. So trinitrotoluene, and you may recognize this molecule, maybe not, but trinitrotoluene has an abbreviation of TNT. So this is TNT, dynamite. So it's TNT. That's that molecule, trinitrotoluene. And then lastly, we have ourselves a benzaldehyde. Looks like I've got a bromo in the 3 position. 1, 2, 3, 4, 5, 6. Which means I can call this 3-bromo benzaldehyde. Or, since this is only a di-substituted one, I could also call this meta. I could call it meta-bromo. You could see both. Both are fine. So that's kind of that's an introduction on how to name some relatively straightforward benzene derivatives. Hopefully you feel a little more comfortable with that. You've seen the ortho, meta, para designations, and that you're more familiar with some of those benzene derivative names like toluene, phenol, benzoic acid, etc. So do some practice, go through this video again and maybe pause on screens like this and try to name all of these yourself, all by yourself. Definitely do lots of practice. Happy studying. Take care.